All right. So if you've had a go at this already, great. But I'll just I'll show you the worked example first, then you can have a go at the tray yourself. So calculate the potential difference in current through each resistor in the circuit below. So this is a combination circuit. We have serial parts and we have parallel parts. So the best thing to do is consider this circuit as a serial circuit. And this parallel section here, we need to convert this to a serial section. All right? So we need to work out what we could replace those two resistors with, you know, a single resistor to make it a serial circuit. Okay, so we need the equivalent resistance of those two resistors so that we can, you know, replace it with a single resistor, and then we have a serial circuit. So those two resistors here, remember our formula, 1 on RT is equal to 1 on, in this case, R2 and R3. Okay, just because that's how parallel works. So 1 on RT, so 1 over 30 plus 1 over 40. So if someone work that out for me, please. Anyone working this out? 1 over 30 plus 1 over 40?
2 over 120 is 7.
What is 7 over 120? 7 over 120 is 1 on RT. All right, so therefore RT, if we flip them both, is 120 over 7. Someone work that out for me, please.
17.1429.
Thank you. 17.14 ohms. Okay. So our equivalent resistance is 17.14 ohms. Now, does this pass the common sense test? Yes, why? Good. It is less than either of these, which it should be in parallel. Good. Go for it. All right. So 17.14 ohms is there. Now, we could replace these two resistors with a 17.14 ohm resistor. Okay, so I probably don't need to do this, but let's just quickly draw up our circuit again. But this time, so we've got 12 volts there, 10 ohms up there, 17.14 there, and 20 down here. So now we have a serial circuit. We've replaced our two parallel ones with a serial, or just a single resistor. Okay. So now we can work stuff out. So we can work out the current flowing through this circuit. So remember, V equals IR. Well, actually, first of all, our equivalent resistance in this whole circuit, we should probably work out first. RT. Now, in a serial circuit, how do we get our equivalent resistance? Add them. So 47.14. So all of our resistors added together is our equivalent resistance. We know V is 12. He's taken it. Okay, 12 volts. No. And so we can work out our current. So V equals IR. So I equals V on R, which is equal to 12 on 47.14. Can anyone work out that current for me? Anyone work that out? 12 on 47.14?
0.25 amps.
Thank you very much. 0.25 amps. So we have a current in our circuit of 0.25 amps or 250 milliamps. Same thing. All right. So now we need to work out the potential difference and the current through each resistor in the circuit below. All right. So R1 and R4 are going to be our easy ones. Okay. So at R1, so we know well, there's a couple of things we know. Actually, I won't do V equals IR yet. We'll do V. We don't know V yet. Oops. So we at R1, guys, thanks. At R1, we know the resistance is 10 ohms. Okay? So at R1, we know the resistance is 10 ohms. Do we know the current at R1? We do. Because in a serial circuit, the current is the same the whole way through it. Okay, so we can consider this, remember, like a serial circuit. So our current is going to be 0.25 amps the whole way through. Okay, so our voltage is going to be 0.25 times 10, so our voltage there will be 2.5 volts. I'll just put R1. Okay, R1's there. This is going to get really squashy at some point. R4, I'm going to put down here as well, but I'm going to write small. VIR. So we know I, because remember, it's the same all the way through our circuit, 0.25. We know R is 20. And so, 20 times 0.25 is going to be 5 volts. Okay. There's R4. Okay, so for R2 and R3, we need to remember that so a couple of things here. Our potential difference. If we measured the voltage at this point and at this point, what would that voltage be? Any ideas? 2.5? Not 2.5. Okay, so remember, our battery is giving out 12 volts, which means that our circuit has to use up 12 volts the whole way around. It has used up 2.5 volts here and 5 volts here. So it's used 7.5 volts in total. So across this section here, it must use up the remaining voltage. Okay, to use 7.5, we need to use 12. The voltage difference across this point will be 4.5 volts. Okay?
Is that so we don't have to work the maths out?
Sorry?
Is that so we don't have to work it out the other way?
For work what out, sorry? Okay. So, this is the only way to work this out. Because, remember, in a parallel circuit, what do you know about the voltages going through R2 and R3? They're the same. They must be exactly the same. Because remember, voltage is how much charge a coulomb, or how much energy a coulomb of charge is carrying. Our coulombs are carrying the same amount of charge, regardless of which branch they go down. So, for R2, we know our voltage is going to be 4.5. We know our resistance is 30, so we can work out our current. So our current is V on R, which is going to be 4.5 on 30. Anyone work out 4.5 on 30? 0.15? Thank you. Now, for R3, same thing. We know our voltage is 4.5. We know our resistance is 40. And so, if someone could work out 4.5 divided by 40, I'm guessing it's going to be 0.1. No, that's not right. 0.1125. All right, so we've rounded somewhere. Okay, but that's all right. So, I think we might have rounded down here or something like that. But we can see that our two currents here should add up to our total current. And they're pretty close to within rounding errors. Okay, so we've got 0.15 and 0.1, which adds up to our 0.25 current. Okay, so we know voltage, current, resistance for each of our 4 resistors. So this is a complex problem. This is about as tough as they get. Okay? You need to assume that the parallel is you know, a serial component, but you need to work out the total resistance for that, or work out the equivalent resistance, to work out the current in the circuit. Once you know the current in the circuit, at least these two are going to be easy, but you do need to think about these two. Yeah?
So, you said to work out the voltage drop across that combination resistor by subtracting from the total voltage, putting all the other. What if you have 2 combination resistors?
Then you're in trouble.
With that?
Yeah, no, then you're in big trouble.
Like
I'd have to see a problem like that.
the next
But,
question.
oh really? All right.